Hello everyone, myself Dr. Ashish Sharma, Department of Physics, DVS College Kanpur. Today I am going to discuss about introduction of the physics. As we can see, like physics has many branches and what these branches are stands for and why it's required to divide physics into different sub branches that we will discuss in today's presentation. So this is going to be outline of the presentation. First, I will introduce about the physics and then its sub branches. So basically, we are considering two major branches: classical physics and modern physics. And then again, classical physics are divided into in sub branches and modern physics divided into sub branches. In the last, I will conclude my presentation. In physics, this is the study of the phenomena happening everywhere in day-to-day life. Like as we can see, whatever the processes are happening with us or around us, the main reason behind that is physics, like moving a train or uh, a plane and all. These all are the examples of the physics, and these phenomena can be explained in terms of the energy, forces, etc., with the help of fundamental laws of nature. So whatever the process is happening, that all followed the fundamental laws of nature. We never see any violation of the any kind of laws, like in case of a force, energy, or mass, or etc. So this is the study of the matter and their associated energy with the help of Einstein's energy formula. And in the picture we can see the famous Einstein formula E is equal to mc square, which says like mass can be converted into energy or energy can be converted into mass. Like if we can see in case of water, when it once we vaporize it, it goes to a gas, and this is a kind of form of energy in terms of heat and all. And once it condensed, it has some kind of a volume with its mass, and then that follows the laws of E is equal to mc square. Physics and its branches. So physics has two major branches. One is the classical physics, another one is the modern physics. Classical physics is it's refers to the traditional forces that were recognized and developed before the beginning of 20th century. So whatever the forces were there before the 20th century, that comes into the study of these forces comes into the classical physics. And the modern physics, whatever the things are coming after 20th century, that comes in the modern physics. Classical physics, it has first branch sub branches is mechanics, which is the study of the forces acting on a body, whether it's in the rest or in the motion. So Newton's three laws that comes into the mechanics, as we are all aware about this. So here the one example I have shown here, how the plane mechanism is working. So what it's making its balance in the sky. So in these images we can say there are some kind of forces, like first is the weight. uh, Due to weight there is a gravity. Second in the upthrust force, lift F1. And then thrust force from the engine and all, and drag, air resistance and all. These are the forces which are once we make the free body diagram of an airplane, we can see the following forces are there, and F1 is balancing Fw, and same time Ft is balancing air resistance. Second is the acoustics, which is the study of the production and the propagation of the sound waves. So, whatever the music we listen and all, the study and all these like beats, bass, all these things are comes into the under the study of the acoustics. So, this is in the diagram we can see here. It's a guitar and how its mechanism is there. So, this study comes into the acoustics. Third branch is the optics, which is the study of the light, and it's divided further into physical optics, and this is based on the production, nature, and the properties of the light. Like what are the properties of the light, how light is formed, and what are the nature of the light, like and I cannot discuss the few words here because then it might be trouble for you to listen these words without any information. So maybe these lectures and these further things can be discussed in the upcoming lectures. Second, in the physiological optics, which is on the part played by the light in the vision. Third is the geometrical optics, which is based on the reflection and the refraction of the light as encountered in the study of the mirrors and the lenses. So one example, I think we you all might aware about the, which is the, in Hindi it's called Indradhanush. So this is the example of geometrical optics. And modern physics, first is the thermodynamics. This is the study of the relationship between heat and the other forms of energy. Second, in the electromagnetism, which is the study of the properties of the electric current, magnetism, and their relationship. So this is again divided further into following sector: electrostatics, which is decided on the basis of electric charge at a rest; electrodynamics, once charge is moving, we study the electrodynamics, and once we have magnetic pole at rest, we study about the magnetostatics. Atomic and nuclear physics. So this is the study of the, as we know, study of the atoms, and as we know that most of the things, everything is made by atoms, and atoms has its structure, like electrons are revolving around the nucleus, as we can see in the diagram. We have electron orbits, and in the centers we have neutron and proton, which are placed inside nucleus. So this study and this all phenomena, like a deep study, we can study in the atomic and nuclear physics. And fourth is the quantum physics. So quantum physics is basically, at very ground level, we have to study the whatever, because few things were failed in the classical mechanics, and for that we have to be study the quantum physics. And quantum physics is basically the deep root study of any physics phenomena. So this comes with the discrete nature of the phenomena at the atomic and the subatomic level, and its forces is on the invisible unit of energy called quanta, as described by the quantum physics. And fifth is the relativistic physics. So whatever, whenever the things are happening with compared to the speed of light, that comes into the relativistic physics. And so there we cannot see the proper length and the proper time, as we can see in the space. The things are happening very slowly because as we know that our space is expanding compared to the speed of light. And so for that study and all, we have to study the relativistic physics. And in the last we have solid state physics. So this is the study of all properties of the solid material, including conductor, semiconductor, and inductor, defined on the concept of electric current conduction. So electric current flows very highly in conductor and in the moderate manner in semiconductor, and it flows negligibly in inductor. So those all study and all we study in the solid state physics. Then condensed matter physics. This is the extension of the solid state physics, where we study the properties of the condensed material, like material which are condensed, solid, liquid, and gases, with the purpose of developing a new material with better properties, so that we can, as we can see in the application manner, like the mobile phones we are using now, the batteries are very developed. And we can see here, like in the case of, as you can see in the case of memories and all, the size is very much reduced, and for that all containment, we have to be study the condensed matter physics. Eighth is the plasma physics. Plasma, as we know, we have the solid, liquid, gas, but fourth state of matter is plasma. So that study we comes into plasma physics. And ninth is the low temperature physics. And this is as we know that most of the processes are happening at the very very low temperature. I don't want to discuss deeply, but as one example is the superconductivity, which is a low temperature phenomena. And to occur that phenomena, we have to be first attain a very very low temperature, and that low temperature techniques and all, that all comes into low temperature physics. And now the concluding here. So now we know the what the different branches of the physics stands for. And as we know, physics is a very wide subject because it covers everything in the universe irrespective of their size and mass, like from the atomic level to the galaxy level. And we are very very small size people if we compare with the kind of a galaxy. And everything whatever the basic रूट्स एंड जो भी कुछ हो रहा है हम लोग के साथ, सभी कुछ चीज़ें आर डिफाइंड बाय द फिजिक्स. And laws of physics never fails in any reference system. सो जो भी फिजिक्स के आपके नियम हैं वो कभी फेल नहीं होंगे, चाहे वो अर्थ हो या चंद्रमा हो या फिर किसी भी प्लेनेट ऑब्जेक्ट, या फिर इंडिया में या फिर फॉरेन में, आप कहीं भी हो, फिजिक्स के लॉज जो हैं आप कहीं भी हो किसी भी सरफेस पे हो वो आपके हमेशा सेम ही रहेंगे. सो किसी भी चीज़ को एक्सप्लेन करने के लिए और किसी भी चीज़ में अगर हमें डेवलपमेंट चाहिए, तो अगर उसकी डीप स्टडी हमें समझनी है तो उसके लिए फिजिक्स इज़ द required, and physics can be understood by the laws of physics. Thank you.